Hi friends, myself Nagaya Siramat. I'm working as assistant professor. So in the last videos, we discussed introduction of microprocessor. This is the second video of microprocessor part. The main objective of this video is addressing modes and assembler directives. So first we'll look on to the addressing modes. What is addressing mode? The way of accessing the data is called addressing mode. Suppose if you want to access the data from memory to the register or from the register to the memory or from register to register. So how you are accessing the data. So that is the meaning of addressing modes. So we have different types of addressing mode. The one is called immediate addressing mode, register addressing mode, direct addressing mode, indirect addressing mode, base addressing mode, index addressing mode, base index addressing mode, and relative base index addressing mode. Now we'll see how we can use addressing modes and what it is addressing mode. The first one, the register addressing mode. In this register addressing mode, the data is transferred from one register to another register. In the instruction, we have two operands, destination operand and source operand. Here, both operands is registers in the register addressing mode. The data is transmitted from one register to another register. So, for example, here move AL comma BL. The move is an opcode and AL is in the position of destination operand and BL is in the source operand. Data is moved from BL to AL. So data is transmitted from one register to another register. That's why it is called as the register addressing mode. Here, what is the data is available in BL? I have 0000 and 1000. So after execution of move AL comma BL, this BL data goes to AL. So AL will be stored as BL. And in the second example, move AX comma BX. So before execution of this instruction, BX contains this value. After execution, the AX will be loaded as BX value. So we are transmitting data from register to register. So this is called as register addressing mode. Next is immediate addressing mode. In this immediate addressing mode, we are transmitting immediate data to the register or memory locations. For example, move AL comma 20H. 20H is the immediate data that we are transmitting to the register. So here it moves the data from 20H to the AL, that is from the source operand to the destination operand. So after execution of this instruction, AL will be loaded as 20H. And the second example, move AX comma 1234H, that is 16-bit data transmitted to the AX register. So after execution, AX will be loaded as 1234H. So immediate data transmitted to the register. And also we can transmit immediate data to the memory location also. Then direct addressing mode. As the name indicates, here the address is specified directly in the one of the operand. So that's what it is mentioned, memory address specified directly. For example, move AL comma 3000H. 3000H is within the bracket. So now it is represented as memory address. The address is specified directly in the operand itself. That's why it is called as direct addressing mode. In this address, I have some data. What is the address in this data? So to find out that, first we have to know what is the physical address of this. So this is an effective address. So to get the physical address, the segment address should be multiplied by 10H plus the effective address. So data segment address, we consider address is 1000H. So 1000H multiplied by 10H plus 3000H. So total physical address will be 13000H. In that 1300H, what is the data is available? 60H. That 60H where we are moving to the AL register, because we are executing move AL comma in the bracket 3000H. In this 3000H I have data 60H. That data goes to AL register. So after execution of this instruction, AL will be loaded as 60H. Then indirect addressing mode. In indirect addressing mode, the effective address is specified indirectly in some registers. That's why it is called as indirect addressing mode. The address is specified indirectly in some register, then it is called indirect addressing mode. Examples, you can see here move AL comma in the bracket BX. In the earlier example, in case of direct addressing mode, the address is specified directly here, but here the address is specified with the help of bx register. Bx having the address, what is that address? 3000h, that is effective address. So what is the physical address of this? So we have to calculate that. So ds will be multiplied by 10h, so ds address is 1000h multiplied by 10h plus effective address is 3000h. So it is 13000h. In that I have a data 60h. That data will goes to EAL after the execution of move EL comma BX. So this is indirect addressing mode. Then base index addressing mode. Here the effective address is the combination of base and index addressing mode. So effective address is equals to base register plus index register. So index register DI or SI. It is not SP, SI. So physical address is equals to segment address multiplied by 10h plus effective address out of these any register, that is effective address value. So for example, move DX comma BX plus DI. The effective address is the combination of base register plus index register. That's why this is example for the base index addressing mode. Then what is the address of this physical address? So how to find out that? So BX and DI is belongs to data segment. So data segment address multiplied by 10h. So data segment address I consider as 0100h, that will be multiplied by 10h plus BX register address plus BI register address. If you add that, you will get the physical address. So physical address is 02010h. In that I have a data 03. In the next memory location I have data AB. So what we are doing here, move DX comma in the bracket BX plus DI. So whatever data is available in this location, what is that location? 02010h. What is the data is available? 03. Lower byte is 03. In the next location AB. So higher byte is AB, lower byte is 03. That will move to the DX. After execution of this instruction, DX will be loaded as AB03. Then last one is relative base index addressing mode. As the name indicates, relative, that is some displacement in the memory location. So effective address will be the base register plus index register plus 8-bit or 16-bit displacement. So effective address equals to base register plus index register plus 8-bit or displacement. So here it is not SP, that is SI, either SI or DI register, index register. So example, here move AL comma in the bracket BX plus SI plus displacement. BX register, base register plus index register plus displacement. This displacement may be 8-bit or 16-bit value. So finally, in this address some value will be there. The data goes to AL. So that's what it is represented here. Then assembler directives. So what it is assembler directives? These are instructions which are not belongs to assembly language instructions. So it gives the direction to the assembler. So if you see first assembler directive, that is assume, what it does, it informs to the assembler about the names of the segment. So which are the segments we are using in the program, that is named by assume. So how to use that? The format of assume is assume seg colon segment name comma seg colon segment name. So where seg indicates what is the segment register. We have the segment register, code segment, data segment, extra segment, stack segment. We can represent in this case CS or DS or ES or SS. Then if you represent here CS, you have to write code segment. So what is the name of that? Then DS data segment, like that. So you can see the example. Assume CS colon code, that is code segment you have to write. Then DB, define byte. So in memory location, which type of data is available, that is specified by the data types. In that first one is DB, define byte. So nothing but we are specifying byte of data available in the memory location. So here the format, the variable, that is name of the memory location name, DB, the what are the value or values are available in the memory location of variable. For example, num DB space 12h comma 14h. These are the values are available in the memory location num. Which type of values are byte value? That's why it is mentioned DB, define byte. So 1 byte equals to 8 bit. So you can see the 8 bit of data here. So then DW, define word. So in the earlier define byte, now it is define word. So word of data is available in the memory location. That is indicated by define word. You can see the format variable space DW space value or values. So here example num DW1234H comma 1F C2H. So I have 16 bit of data in the memory location num. That's why it is represented as DW define word. Then define quad word DQ. So it loads 32 bit of data. So num DQ 1 2 3 4 5 6 7 8 H. So 32 bit of data are loaded in the memory location num. That's why it is represented as DQ. Similarly, define double word 64 bit of data. That's why it is represented as DD. 64 bit of data is available in the memory location num. The last one in data types DT, define 10 bytes. So here 10 bytes of data is loaded in the memory location num. So which type of data is available in this memory location? DT, that is define 10 bytes. Byte of 10 bytes of data is loaded in that particular memory location. From these we can understand which type of data is stored in the memory location, so that we can access from the particular memory. Then dup, that is dup stands for duplicate. Duplicate in the sense how many memory location you want to make duplicate. You want to load some value, your user defined value in that particular memory location. Then how to use this? So you have to give the variable name, then data type either db, dw, dq, dd or dt. Then how many locations you want to make, number that you have to give. Then dup of in the bracket 0. If you give specify 0 here in the memory location num of total 8 location will be 0. It loaded 8 locations of the num will be 0. If you put question mark also it loads 8 locations will be 0. Suppose if you represented here a, so then 8 locations of this num will be loaded as a. Then equate, as the name indicate, it equates some value to the variable, what variable you will specify. So here the num equate 45. So 45 I am equating to the num, nothing but wherever you are using num in your program, so num will be replaced by 45h. So the 45 is allocated for the num variable. Then dot model, so it gives the information to the assembler the which are the segments we are using in the code. So if you specify dot model small, then we are using one code segment, one data segment in the program. If it is dot model medium, then one data segment and multiple code segment, more than one code segment we are using if it is medium. Then if it is compact, one code segment and multiple data segment, one code and multiple data segment. If it is large, multiple code segment and multiple data segment, that is dot model large. Then org stands for origin. Suppose if you want to start your data segment address from the exact address, so that address you can specify along with assembler directive org. So that's what here org 1000h. What happens? The address of the particular data segment variable will be starts from that particular memory. So for example, data one I defined after the org. So data one address is specified as 1000h. So in that 1000h, I have all these data. Then page. So here it specifies how many lines and how many characters are present in each line, that is represented by page directive. Here you can consider example page, first bracket 10, second bracket 123. First bracket indicates how many lines, how many rows are present in the page. Next second bracket indicates that is 123. In each line, in each row, we have 123 characters, that is indicated by 123 lines and columns. So lines represent how many rows, columns represent how many characters present in each row, that is page directive. Then E1 directive. See, in case of org directive, we have started address from 1000h. Suppose the 1000h is assigned to data 1. or suppose 1001H is assigned to data 1, then your this address is odd address. But if you want to make U1 address, you want to start that particular address memory location from the U1 address, then we can use for U1 directive. So we can see here this U1 directive instruct to the assembler to increment the location of the counter to the next U1 address. So if you are given U1 odd address also, but if you specify the directive U1 with some variable name, then that variable address will starts from the U1 address. Then PTR, pointer. As the name indicates, it points the either byte of data or word of data we are taking from the memory location, or we are pointing either byte of data or word of data in the memory location. That is the meaning of PTR. It points each type of data, either byte or word. If you specify byte pointer, then it is pointing byte of data in the memory location BX. So here instruction is increment. So it increments only byte of data of the BX. If a specified word pointer, then word pointer will be incremented by 1 times, that is INC. Then length. So this directive helps to find the length of the string. For example, in the data segment, if we declared string 1 space db space VTU examination. VTU examination is the full string. So now I want to find out what is the uh, length of this VTU examination. How many characters are available in this VTU examination string. Then what we can do, we can use length directive. So how to use move cx comma length string 1. String 1 is the name of the that string, that whatever video examination is there, that is loaded in the string 1 memory location. So that is the string 1. So if we give length string 1, this length directive will load how many characters are present in this string 1. Then that will be assigned to the cx register here. Move cx comma length string 1. Then offset. As the name indicates, it loads the offset address of the memory. For example, move si comma offset data 1. Data 1 is the memory location name that having 16-bit address. That 16-bit address we are calling it as offset address. So that address will be loaded to the si with the help of offset directive here. Move si comma offset data 1. It loads that offset address of data 1 to the si register. So why we have to load to the si? If you want to increment that memory location, so we have to load that memory variable name to the some register, then only we can increment that particular memory location, or we can decrement memory location. That purpose we are using offset directive. Then public. Suppose you are declaring some variable as public in the present model. If you want to access that variable in the upcoming models, what we can do, we can just assign public. So whenever you want that, we can access the value of the variable declared as public. That's what it is written. These two variables are public, so these are available to all models. The value of these variables are available to the upcoming models. Extern. Suppose you already declared some variable in some other models, that value of those variables you want to access in the present model, then in the present model those variables we can uh, define with prefix as extern. Then what will happens, we can access those variable values from the other model to the present model. That is the difference between public and external. In case of public, we can access for all the models if we declared once public with variable names, and if we define extern with variable name, so whatever variable value is declared in the earlier model, that we can access in the present model, that is extern directive. Then PROC and NP. This is regarding procedure. So first procedure is nothing but you are writing some line of code separately from the main program. That is called as procedure or subroutine program. You are writing some code out of the main program. That is called as subroutine program or procedure. So how to use procedure? So we have the format to write the procedure. The name PROC. PROC is the start of the procedure and name is the name of the procedure. Then attributes. So that procedure is belongs to same segment or other segment, that is indicated by attributes. So in that attribute, we have two attributes, that is near or far. If you mention near, that is within the same segment. So you are writing the code that is in the same segment. If it is mentioned far, so whatever you are writing the procedure that is out of the segment, that is you are mentioning in other segment, that is far. So next you have to write the main code of the procedure. Then name, again it is name of the procedure. End p, end of the procedure. So you can see here PROC, start of the procedure, end p, end of the procedure. So I told attributes two types, near and far. Near is within the same segment, far is outside the same segment. Examples, if it is near, can specify attribute is near, and I give a name of the procedure is fact. Then here you can write the main body, that is main body of the procedure, main code, then end the procedure. If it is far, can mention far, and you can write the main code of the procedure and end the procedure with the end p. Then macro. So this also similar to procedure, but if we have short code, that is just few line of code you want to write separately from the main program, that is written in the macro. Suppose you have more than 5 or 10 line of code that we are mentioning in the procedure. So if it is more line, that is called it as procedure. If you are using very few lines of code, that we can mention in the macro. Then how to use macro? It is similar to procedure. First, name of the macro, then macro, start of the macro, parameter. So what is the name you are given to the code, that we can write it as parameter. Then end the macro. Example, DISP. So here I given name of the macro is DISP. Macro is the directive, and data, that is here I want to display some message, so that I given name it as data. Then end macro. So this is the code move h09h LEADX comma data in 21h. See, 3 line of code. So this short code is written within the macro. But in case of procedure, we are writing more than 4 or 5 line of code. That is the use of procedure. But macro is used for short code. You want to execute this short code number of times, then you can use the macro. Here, what is the use of this code is it displays some messages. For loading messages, we wrote the code move h, 09h, LEADX, data into 21h. We can easily understand in the program how we can use this code. Then what are the main differences between macro and procedure? As I told, the macros is used for small code and procedure is used for suppose if it is more than 5 line of code, that is written separately from the main program. Macro also is written separately from the main program. Procedure is also written separately from the main program. But the main difference main is macro is used for short of code and procedure is used for some more than 5 line of code. So once if you write the procedure or macro separately from the main program, then what will happens? See, if you write macros, and if you are calling the macro, suppose if you are calling 100 times of macro in your program, so 100 times the memory is allocated for the macros. That's what it is. The first point says the corresponding machine code is written every time a macro is called in a program. So machine code will be written, that is memory is allocated for the macros. If you call 100 times, 100 times memory is allocated. But in case of procedure, if we called 100 times procedure, only one time the memory is allocated for that. So that is the first point. Second point, so program takes up more memory. So if 100 times more memory is allocated for that, in the sense it will be more memory. So it takes more memory in macros, and in case of procedure, it takes less memory because only one time memory is allocated for the procedure. Then third point, no transfer of program counter. What is this program counter? The program counter will loads the next instruction to be executed. So here, so if you are calling the macros, the program counter, it won't goes to the macro program. So within a short period that will be execute. So no transferring of program counter in case of macros. But in case of procedure, once if you call the procedure, the program counter jumps to the procedure program and it will execute the procedure, and again it returns back to the main program. So there is a requirement of transferring of the program counter in case of procedure, but in case of macros it is not required. Then fourth difference, no overhead of using stack. Nothing but, see, if you are using program counter, the program counter will load the address of the next instruction in the stack segment. But here there is no jumping of program counter, so no use of stack. But in case of procedure, the stack is required for loading the address of the next instruction in the stack segment. Then fifth difference, in case of macros, is execution is faster because the line number of lines is code is less, and it will be execute faster. But comparatively, uh, in macros, in procedure will be the execution speed is less. Then assembly time is more in case of macros, and assembly time is less in case of procedure. And last difference, what is the more advantage of macros is, so when you want to write few line of code uh, number of times, we can neglect that. We can use macros, and we can use by using macros we can write only one time of code in the program, and we can access n number of time. That is the advantage. If you want to call those 3 line or 4 line of code n number of times, we can use macros. Suppose you have 10 line or 15 line of code that you want to call 10 times in the program, then we can use procedure. That is the advantage of procedure. Thank you for watching. Please like, share, and also subscribe. And if you have any queries, please inform. Thank you once again.